Hello, Advanced Algebra 2 students. This is Coach DePaulo back with video number 5 for Unit 4. This is for Lesson 4.4, and we are going to be solving polynomials with factoring. So we spent the last 5 days or 5 lessons learning how to factor polynomials. We've used grouping, we've used the distributive property, we've used guess and check, and we've used the difference of two squares. Now we're going to go to the next step and we're going to solve those. So just so we understand, like today there are 5 steps in the solving process. I gave you a flow chart for factoring process, and so that entire chart is now just one step of the solving process. So in this video today, if I say step 1 of solving, we're going to be talking about that. But if I say step 1 of the factoring process, remember that's going to be to use the distributive property to make A positive and also to take out the GCF, or the greatest common factor. So I just don't want to make sure that we don't get confused on those. So what is the goal today? So the goal today is to solve. And in the future, we're going to take those solutions and we are going to graph them. So here is the graph of our very first problem we're going to do today. And if you look down here on the x-axis, the solutions are 6 and 7. And that will be the two solutions to the equation. So later on in chapter 5, we're going to graph quadratic equations. And the first step will be to find the x-intercepts, which are the solutions. And then we'll have another process for graphing the entire parabola. So that's kind of where we are headed. So let's go ahead and get started. So looking up here at the top in step 1, it says that if we see different forms of x, where one will have a square and one will have an exponent of 1, if we see that in the problem, then we're going to need to factor. So in order to factor with an x squared, we need to set the equation equal to 0. So if we look at example number 1, it is already set equal to 0. Step 2 is now to factor the equation. So remember, in step 2, we're factoring. So the step 1 of the factoring process is to make sure A is positive, and it is because it's positive 1. To look to see if we can factor out anything, and we cannot. Step 2 of the factoring process is to count the terms. It's 1, 2, 3 terms. So we're going to use the guess and check method. So we're going to put 2 sets of parentheses, set this equal to 0. And this goes back to lesson 4.3, day 1, where A was 1 in front of the x squared. So we knew right away that we were going to put an x and an x there. And we needed to fill in these two. And those two blanks, if you remember, were going to be the factors of 42. Because there is a plus sign right here, these two numbers need to add up to negative 13. So first, let's get them to add up to 13. So we're going to come over and look at our factors of 42. And it turns out the two sets of the set of factors that adds up to 13 is 6 and 7. So we know we're going to use 6 and 7. Now 6 and 7 by themselves add up to 13, but I need them to add up to negative 13. So I'm going to make both of them negative. All right. Step number 3, it says set each factor equal to 0. So I'm now going to remember this is a factor. And this is a factor. So I'm going to set those factors equal to 0 because one of them has to be 0 if this If this side of the equation is going to equal 0, then this factor has to equal 0, or this factor has to equal 0. So we're going to solve these by adding 6 to both sides here and add 7 to both sides here. So my solutions are 6 and 7. And then we are going step 4, that's to solve. Okay, and then we're also going to write the answer in set notation. So we're going to say x such that x is an element of 6, 7. We're putting 6 first because these go in ascending order, so smallest number first. All right, let's go over to number 2. Let's go ahead and get started with number 2. Step number 1, do I have 2 different types of x's? I do. And I got a square there and an exponent of 1 there. So I need to factor. First step of factoring is to set these equal to 0, which I've done. Now we're going to, the first step of solving is to set it equal to 0. The first step of factoring is to take out anything they have in common, and we can take out an 8. When we take out an 8, we are left with x squared plus 5x plus 32 is equal to 0. All right, now you may ask, what do I do with the 8? Well, we don't need it. It is a factor, but it's not a factor that produces a solution. So we're going to get rid of it by dividing both sides by 8. And so when I do that, I'm left with x squared plus 5x plus 30. Oops, sorry. Got this plus 32 here. That's supposed to be a 4. That's a mistake. Let's go back up there and fix that. Oops. Let's go back and fix that. This is going to be a 4. Okay, now real quick, does the 8 matter then? If I'm just going to factor it out and get rid of it, does it matter? So the answer to that depends on the question you're asking. Today, the question we're asking is, what are the solutions? My answer to you today will be no, the 8 doesn't matter. Next unit, when the question is, how do you graph this, the 8 will matter, and I'll explain to you how it matters then. But let me show you that it doesn't matter. Let's go back to Desmos, and let's turn off that first equation. Here is the graph for the first equation without taking out the 8. Okay, here's the graph when I take out the 8. And what I hope you notice is that the x-intercepts are the same. So the solutions are the same. That's why today the x doesn't matter. The x will matter when we're about to graph, because you can definitely see the green graph and the blue graph are not the same. So we'll have to use the 8 in Unit 5, but in Unit 4, when we're solving, we do not need it. Okay, let's go back over here, and we're going to do this part rather quickly because we've got another easy equation where x is 1. So this is going to be x and x. The factors of 4 that add because of that plus sign up to 5 are, as we know, 1 and 4. So 1 plus 4 gives me 5. So I'm going to use 1 and 4. I need both plus signs because I got to add up to positive 5. Set the factors equal to 0 and solve. I'm not going to take a lot of time here because y'all can do this. Okay, set notation, x such that x is an element of the set -4, -1. Remember, -4 is smaller than -1. All right, we're going to skip number 3. That problem's not going to give us any additional information or help, so we're going to go over here to number 4. Okay, let's go and look at this problem right here. Okay, first thing that I want to do is look at step number 1 for solving. And step number 1 for solving is check, do I have different forms of x? And I do. I got a square and I got a 1. So I need to factor. Step number 1 of factoring is I need to set this equal to 0. So I'm going to go ahead and subtract 4 from both sides and get 12x squared plus 56x minus 196 equals 0. Now, I'm pretty sure that I can take something out, and I know I'm 100% sure I can take out at least a 2, because remember, we've talked in class, if the numbers are even, then they're divisible by 2. But how about something bigger, like maybe a 4, or maybe a 6, or maybe a 12? Now, I've asked this on several occasions in class. What is the largest number we could hope to take out? And it doesn't matter what the factors of 196 are and 56 are, because the largest factor we can take out will be the largest factor of this number because it's the smallest. So the hopefully, or what would be the easiest is, can I take out a 12? So if you're not sure, go to the calculator, go to y equals, and type in 12 divided by x, and always put the smallest number first, put the next number in the middle, and put the largest number last. And then what we're going to do is we're going to go to the table, and we're going to notice in column 1, the largest factor of 12 is obviously 12. So let's see if it's in the middle column. And if you notice down my factors of 56 are 56, 28, 14, and 8. No 12. So next thing I'm going to do then is I'm going to check 6. 6 is the next largest factor of 12. Again, I'm going to go to the red column. I got 28, 14, 8, 7, no 6, because it goes from 7 down here to 6.2, then 5.6. So no 6. How about 4? Okay, 4 is in the blue column. Definitely is a factor of 12. Scroll down, and yes, 4 is right there in the middle column, so it's a factor of 56. How about 196? Scroll on down, and you'll notice that right there in the green column, 4 is a factor. So 4 is the largest factor of all 3 terms, so I'm going to take out the 4. And I get 3x squared plus 14x minus 49 equals 0. Okay, I'm not going to show it this time, but divide both sides by 4. So I need to factor 3x squared plus 14x minus 49. All right, in this unit, because we are learning to factor, I need to show the steps. So I need to write over here factors of 3 are 1 and 3. Factors of 49 are 1 and 49, 7 and 7. Okay, so what are we doing? First thing we're going to do is we are going to, we know that we have to have a 3x and an x. That's my only choice because over here it's my only set of factors. Okay, so now remember, my O is these two multiplied together. My I is these two. And in this case right here, we need to subtract 2 things and get a 14. That's our goal. Okay, subtract 2 things and get a 14. So let's be efficient and say, you know what? 49 is going to produce something pretty big. So let's try 7 and 7 first. So the outside, 3 times 7 is going to give me 21. The inside, 7 times 1 is going to give me 7. Can I get to 14 from 21 and 7? And I can. If I subtract 7, I'll get 14. So I need my 7 to be negative. Okay, where did that 7 come from? Did that come from the outer 3 times 7? Or did that come from the inner 7 times 1? It came from the inner, so I need to make the inner 7 negative, the outer 7 positive. So there's my factors, 3x minus 7 and x plus 7. All right, and then here's the easy part. Set each factor equal to 0 and then solve. Okay, subtract 7, or add 7, sorry. 3x is 7, so x is 7/3. Subtract 7 from both sides, and x is negative 7. All right, put them in. X, let's see, x such that x is an element of negative 7, 7/3. There's my answer. Okay, let's go down here, and here's what I want you to do. I want you to pause the video, and I want you to just get these next two, which should be 5 and 6. They got misnumbered, so this is 5 and 6. I want you to just set them equal to 0. Let's just practice doing that because we've got the factoring part down. Okay, pause the video right now. All right, let's see how you did. So first thing over here, do I have to set this equal to 0? I got a square, I got an x with a 1, I got an x with a 1. So I'm going to need to factor. So the first step of factoring is set it equal to 0. So let's go ahead and subtract 8x from both x's. Those will cancel. And let's add 5. Those will cancel. So I get my 0 over here. And then on this side, I get x squared plus 4x plus 3, right? You can take it from there and you can factor. Okay, answers turn out to be x such that x is an element of -3 comma -1. All right, over here. Okay, do I need to set this equal to 0? Again, I've got a square there, I've got a 1 there, I've got a 1 there, I got a square there. So definitely have to do some combining. So, and setting equal to 0. So I'm going to add k squared to the squareds. I'm going to add 7 to the constant. And I'm going to add 4k to the linear term. So I get 0 over here, 28k squared, negative 204k, and 56. All right, and so that's, again, we can take this from here. This number 6 is just like this one up here. Factor something out, or use the distributive property to take the GCF out, and then factor using guess and check. Okay, and then of course this one right here is just as easy as this one right here. So, all right, let's go to the back. Today in this lesson, we're only going to be doing one more problem. We're going to do number 4. We'll pick up with lesson 4.4 day 2. We'll pick that up tomorrow, and we'll actually do these 2 word problems, and we will do some, we'll take these radicals over here and we will simplify them. So we'll do that tomorrow. All right, so last day, so you can get some homework done. Okay, also, if you're watching this video and you're trying to stay up, the homework is only 1 through 9 odd on the assignment page. Okay, and that's on the first assignment that has that many problems. Okay, so step number 1, do we need to factor? And the answer is yes, because I've got a 2, and this time I got a 1 and a 3. So I definitely need to factor. So set it equal to 0. That's done. Okay, how many terms? 1, 2, 3, 4. 4 terms means we get to group. Yay, we get to group. Now, don't write this down. I'm just going to make a point here. When we did grouping back on lesson 4.1, I wasn't there that day. I did make a video though. There was a sub. But step 1 for grouping was to rewrite the equation so that the exponents were in descending order. But then when we started the homework, it didn't really matter. If you didn't do that, it never made a difference. But today, I just want you to see, here's one of the examples where it does. So if we don't rearrange and we group like this, okay, this first one, I'm going to take out a R, and I am left with 64R plus 1. And on this one, I'm going to take out an 8, and I'm left with R cubed plus 1. So I can't solve this because remember, the next step of grouping would be that these two would have to be the same, and they're not. So what do? Well, we rearrange these. If this is going to work, it will always work if you rearrange with your exponents in least to greatest order. Sorry, greatest to least order. All right, so there's our rearrangement. I'm now going to group. Okay, in this first group on the left, I can take out an 8R squared, and that leaves me R plus 8. And in the second group, R and 8 don't have anything in common except for 1, so I do need to take that out. I need to take out a 1 because remember, when we're grouping, I've got to have a term here so I can put it with this term and get my second set of parentheses. So what do we got? We've got r plus 8, and we've got 8r squared plus 1 equals 0. All right. Step 3 of solving, set each factor, which r plus 8 is a factor, set it equal to 0, and 8r squared plus 1 is a factor, set that equal to 0. Okay, subtract 8 from both sides, so over here r is negative 8. Now this one is going to require some old information to finish. Okay, first move the 1 over, 8r squared equals negative 1. Divide both sides by 8, so r squared is negative 1/8. To get rid of the square term, we are going, or the square on that r, we're going to take the square root. So r is equal to plus or minus the square root of negative 1/8. Now, we're not allowed to have that negative sign inside that radical sign. So how do I get rid of it? Well, if you remember back to your honors geometry class with Miss Rainwater, she taught you that if I had something like the square root of 20, that I could separate that into two factors, with one of them being a perfect square or something I could take the square root of, and then my final answer would be 2 square roots of 5. And that's actually what we're going to practice tomorrow. Well, we're going to do the same thing here, except with this one, we're going to separate the square root of negative 1/8 into the square root of negative 1 and the square root of 1/8. And we're going to do that because I know you don't remember this, but way back in Unit 1, on the second day of school, we did notes. Oops, that's Unit 4, sorry. So Unit 1, Lesson 1, in Lesson 1.1, when we defined imaginary numbers, we said that the square root of negative 1 was I. So we are going to come over here, and we're going to make this negative 1 I. So final answer, r is plus or minus I square roots of 1/8. Now that is an imaginary number. We can't graph it. All we can do is write it. So how do I put this and this in a set? Okay, and so it looks like this. We're always going to put our imaginary numbers first, r such that r is an element of, and we're going to separate the plus and minus into minus I square roots of 1/8, I square roots of 1/8. So there's our two imaginary terms, and then negative 8 is our one and only real term. Now I told you our goal of this is to graph. So what does this graph look like? So let me show you. Okay, so this graph looks like this. Okay, so notice over here next to the negative 8 is our point where the line crosses the x-axis. But notice it's going to go up, and it's going to keep going up for quite a while, all the way to like 610 actually. And then it's going to turn around and come back down. But instead of this graph continuing on down and crossing the x-axis, again, it stopped at 8, and then it turned around and went back up, and it's never going to come back again. So this negative 8 is our one real solution. All right, so that's it for the notes for today. We will do number 5 and the 2 word problems tomorrow, and then we will come over here and practice some perfect squares, okay? So, or simplifying radicals. So we'll do that tomorrow. Hope you have a great night.